Momentum! What just happened?
Dude, did that break?
All moving things have momentum. Momentum is quantified as the object's mass times the object's velocity, which means that the faster something's going, the more momentum it has, and also the heavier something is, the more momentum it has.
To show the relationship between weight and momentum, I'm going to be using this pool ball and this golf ball. As you can see, the pool ball is obviously much heavier, so when we send the golf ball at the pool ball, it only moves a little bit, as opposed to when we do the opposite, we send the pool ball at the golf ball. It has much larger displacement.
Show the relationship between velocity and momentum. I'll throw this golf ball with a small mass against this pool ball. Now when I throw it softly, you can see that its momentum is very small. But when I throw it hard, it's got a much bigger momentum.
Poker, and this is the science crash. As you can see, when the longboard hit the grass, I continued moving because I had momentum, whereas the board was stopped by friction of the grass, therefore it did not have any momentum.
When a moving object collides with a stationary object, the momentum is transferred into the stationary object, causing the stationary object to now be in motion. The momentum before the collision and the momentum after the collision is the same. This is because of a property known as the law of conservation of momentum, which states that momentum can neither be gained or lost in a collision.
Me and Taylor are on rollerblades. Since we're standing here, we have zero momentum, so the total momentum is going to be zero. After we push off each other, we exert force in an equal but opposite manner, so the momentum is still going to be total out to zero.
Real-world example of force and momentum is if you were to try to move a table. When the table has no momentum and it's not moving, you have to apply more force to get it started. As opposed to if the table was already moving and it already had momentum, it would take less force. To that last example, if you were to try to move the table a certain amount of distance in a short amount of time, it would require more force than if you were to move the table over a longer period of time. The first time I rolled the ball, I was using a 7-pound ball, and with a very little mass, it didn't generate enough momentum to knock down very many pins. However, in the second roll, when I used a 16-pound ball, the ball had a lot more momentum and knocked down the rest of the pins. Both rolls, I used a ball with the same amount of mass, so the variable that changed in the momentum equation was the velocity. Now in the first roll, I rolled it softly, so the ball didn't generate very much momentum, therefore it didn't knock down very many pins. Now in the second roll, I rolled it much faster, and it generated more momentum and therefore knocked down more pins.
Ooh, the Pacers are gaining some momentum.
No, they're not. Hey Conrad, you know how you see collisions in everyday life?
Yeah.
Well, there's two types of collisions, inelastic and elastic.
Well, perfectly inelastic collisions are when an object collides with another object and then those two objects move together as one mass. Like when you jump off of a dock into a boat.
Well, elastic collisions are when two objects collide and then they return to their same shape and don't lose any kinetic energy. Oh my, it's quite a bit nippy out there. Alright, so now that we've been talking about momentum and forces and collision, that's all great and everything. But what we should really be focusing on is physics in real life. Real world application of these ideas is important. Now the forces in the real world, they're not constant. In experiments, we do tend to keep them as that. But in the real world, the magnitude of forces change. We can see that the forces will increase, climax, and then decrease. Now, dealing with elastic collisions and inelastic collisions, excuse me. Inelastic collisions, you never really see any perfectly inelastic collisions in real life. That is to say, two objects will never collide and then stick together. Also, elastic equations really aren't that common in the real world either. Because, let's take billiards for example. When the balls hit each other, there is a decrease in kinetic energy. Let's say sound. Some of that sound energy will be let off. Another example would be kicking a football. When your foot hits the football will deflate and then go. There's some kinetic energy lost right there. Now, as you can see, these two cases are pretty limited and pretty extreme. However, there is an exception between these two. That'd be just inelastic collisions. That would mean the two objects will bounce off each other, and then they will separate, but there will be some decrease in kinetic energy.
All moving things have momentum, which is why it's such an important topic. Thank you for taking time out of your day to listen to our video.